Good afternoon, ladies and gentlemen. Welcome to the workshop that we are going to be working with annuities. We are going to start with what is an annuity. Okay, an annuity is when normally we've been working with one principal amount whereby we had a future value equal to a principal value into 1 plus I to the power n. There was only one principal value. But now, if ever you want to think about the annuities, it's all about you've got more than one principal, okay, which is the number of payments. Okay. I mean, it is easy. That's what we do mostly all the time, whereby you would want to deposit maybe money in the bank account maybe every month. That would be an annuity. The minute there are multiple payments, that is an annuity. Okay. So what makes the annuities unique is because they are equal size and then it's equal intervals. That means you'll find that the annuity has got equal amounts, maybe 500 per month. It's equal intervals and equal amounts. And what is important for us to understand what makes an annuity unique would be the time of when the payments are made helps us to differentiate different types of annuities. Okay, the time, if ever you are doing a payment at the beginning of the month, we are talking about the annuity U. That is a special type of an annuity. And if you are making payments at the end of the month, I'm making an example that the payments are made monthly. If you're going to make the payments at the end of the month or end of the year or end of the quarter, that will be that is called what is it called at the beginning of the year, at the end? That is an ordinary annuity. And then there'll be the one which is called deferred. It's a special kind of an annuity. It is an annuity which has been deferred. You start paying the payments at the middle where the investment has already started. Okay. And then there's also the one which is going indefinitely into infinity. That is the perpetuity. And then there's the one which is increasing every time there's a constant amount. Is when maybe you're making a constant payments for a specific period and then find that that amount is increasing. You've been paying 500 per month, and then after a specific period, there's an increase. There's an increase maybe to 600. So that would be an increasing annuity. So those are the different types. They are defined by the time on when the payments are made. Okay. We are using compound interest and not simple interest. So what is very, very important when we are working with annuity is to make sure that the payment period must be equal to the compounding interest period. For example, if you are making monthly payments, the interest rate needs to also be a monthly rate, must be compounding monthly. Should you find yourself that you've got different, you are paying monthly payments, but the interest is compounding quarterly. That means you need to convert that interest into an equivalent a monthly interest. So then you've got similar units for the payment periods and also for the interest. That is very important. Okay. We are saying it's equal size payments. We are saying we're using compound interest, and then these are important defining features of the annuities. We are going to be looking for those when we are analyzing the context for us to be able to calculate the annuity. Okay, so let us first talk about the first type, which is defined by you are making payments at the end of the month, not the month necessarily, but at the end of the period. Okay, or if the period is not specified, if you read the context and then the period is not specified, the assumption is that is an ordinary annuity. Okay, this is how it is defined on the on the timeline. Let's say this is T0, that means this is now, and then the following period, maybe it's the month, you are making monthly period payments. This is T2, this is T3, and so on until TN. So now you are not making any, it's the 1st of, let's say it's the 1st of April, you are not making any payments. You'll start making payments at the end of that month, which is the beginning of the following month. That is an ordinary annuity. Same features. The payments needs to be equal all the time. Okay, they need to be equal. That's the same amount. We are using compound interest. The compounding periods needs to be the same as the payment periods. And then here we identify this if you see that the payments are made at the end. Once you analyze this from that context, you know which formula to use. Okay, so here is the defining formula for ordinary annuity. You've got two things that you need to keep in mind. One will be the present value, okay, and then one will be the future value. That's what we know from the compound interest formula, that there is a future value and also the present value. And then the present value of annuity is the amount of money that is needed right now at this present time in order to generate future payments. And the future value of the annuity will be the total value of the payments at a particular time, at the end of the time. Okay, so now we are going to first discuss the aspect of present value. Okay, so the present value formula, it is defined by this formula. Okay, however, if ever the time is compounded, remember, if you've been attending these workshops, you notice that I was emphasizing that when we are writing these formulas, let us focus on the compounding period formula, because it does not make any confusion. You know that this is a formula that you are going to be working with. So here's the formula of a present value. Okay, this is the present value for the ordinary annuity. You need to be able to differentiate these, guys. You need to know, how does a present value for the ordinary annuity, how does it differ from the present value of the annuity Q? Okay, so now identify these formulas. You don't have to memorize them, just identify them and see the difference between those formulas. So I'm going to do this step by step. Okay, so here's the first example. This is an example that we are going to look at when we when we are doing ordinary annuity for present value. First thing first, while you're working with this, you need to draw your timeline so then you can see what is going on there. Okay, so draw me your timeline. You are asked to determine the present value. Okay, the present value will be the value at this point in time. That will be your T0 at this current moment. You are asked to find the present value of equal payments, okay, of this amount per month for 9 years at 7.5 per year compounded monthly. Okay, so now let us put this thing in the timeline. The payments, remember we said if ever it is not specified when you are going to make the payment, the assumption is it is an ordinary annuity. That means the payment is made at the end of the period. We are working with the months. So the first month is T1. So at the end of the month now, T0, you start making the payment there of 5,000. You'll make a payment there at T2 until you go to TN, until your TN will be 9 years. You are told that your thing is 9 years. So now you've got 9 there. That is 9 years. And then you have the interest rate, which is compounded monthly, and also the month the payments are monthly. So we are happy now. The compounding, the payments periods is 12, and also the interest is compounding at 12. So we are happy. We don't need to worry about converting anything. Let us write this into a mathematical form. We know that our R is equal to 1,500. Okay, we know that our I is equal to 0,075. We know what the compounding periods is the same, so we don't need to be worrying about converting anything. It is equal to 12. And we also need to know about N. Okay, that is the number of payments. The number of payments would be, we also need T before that. Our T, this annuity is for 9 years, so it is 9. So our N is 9 multiplied by 12, which is equal to 9 multiplied by 12. I don't know what is 9 multiplied by 12. Is it 86 or 96?
108.
108.
Pardon?
108.
Is it 108?
Yeah.
Okay. And then after you have done that, I'll just show the formula and how you can substitute. However, you are encouraged to use a calculator, guys. You cannot be doing these calculations. They can make your mind go all over the place. So the formula that you need here, it is P is equal to R. I'm just writing the formula, which is 1 plus your nominal interest to the power N minus 1 divided by Jm over M into 1 plus Jm over M. So I'm just doing this thing just for substitution purposes. Substituting everything, you're going to have 1,500 into 1 plus your interest rate is 0,075. It is compounding your M here. It is just 12 to the power. Our N there, it is 9 times 12 minus 1 divided by 0,075 over 12. What is this? Into 1 plus 0,075 over 12. Okay. At this point, you can just substitute everything into your calculator. This is one-step thing if you don't have a financial calculator, but I know that you've got financial calculators. So you can just plug in this thing and then it will give you an answer. And I'm not going to take you through on how you use your financial calculator because we've got different financial calculators. If you are struggling on how to use yours, you can even go to YouTube and enter how do I calculate a present value of the annuity using whatever calculator that you have. So you can just in one step get the answer there. Your answer should be equal to 117,545.50. Okay. So this was beautiful because the payments are the compounding periods are the same as one of the interest, the compounding interest. So we don't have to be worrying about adding any extra things. We are going to look at the one whereby we need to be converting one interest into an equivalent nominal rate. Okay. Now remember, in all these calculations, we are looking for the future value, okay, and also we are looking at the present value. So here is the formula for a future value of the ordinary annuity. Make sure you are able to contrast this one with the annuity due. So then when you are asked a question, maybe you are asked to analyze a formula, you know what is the difference between the two. Okay, so now this will be the future value, annuity, and then similar. It's not similar. There are different components. But the way we do calculations will be similar to how you would calculate the present value. So this will be the formula. Let us look on the example to see if ever we are able to first analyze which formula to use. Okay, here is the question. Okay, this is a young lady, Denise. Okay, Denise has just started a new job and wants to save money for the future. She decides to deposit 1,000 semi-annually. Okay, remember semi-annually, she is depositing it twice per year. So your compounding periods there, it is 2. Okay, for semi-annually, that means at the end of each of each 6-month period, that is twice per year. Her money goes into an account at Cape Town Trust Bank, and the account receives this interest rate per annum. However, this interest is compounding semi-annually. Okay, you see that the interest is compounding semi-annually and the payments are being paid semi-annually. So here we've got similar units, okay, compounding units. So we don't need to worry about converting anything. So we just need to write this into, you can even, I think it is always helpful to have your timeline. Okay, here's your timeline. You are starting at time 0, okay? That is now, okay? And then you only start making payments because this one, they are saying now, her money, new job, she wants to save money. She decides to save at the end. Here's the thing, at the end, and you know you are talking about the ordinary annuity. So you've got T2 until TN, that is the end of the period. And then the end of the period, your TN is equal to 40. Okay. And then how much money will Denise have in her account? That means we are looking for the amount here. Okay, the future value, that's what we are looking at. And then we are told Uguti, let's write this into a mathematical symbolic form. We know that our payments is 1,000. Okay, we know that the compounding units, it is semi-annual. It is semi-annual, that is 2. Okay, we know that our T is equal to 40. Okay, we know that our interest is equal to 0,096796. Okay, and then we can get from here, we know this implies that our N is 40 multiplied by 2, okay, which is equal to 80. Okay, so now what is the formula for the future value? The formula for the future value is equal to R into 1 plus JM over M into the power N minus 1 divided by JM over M. Okay, this is the formula for the future value. I'll just substitute without going through the calculation, because from here you can just, once you know the components, okay, you can easily go to your financial calculator to get the answers. So your R is 1,000 into 1 plus your interest rate. There is your interest rate it is 0,0796 divided by your m there is equal to 2. Okay, this is to the power, our n, we've already got our n. Our n is equal to 80 minus 1 divided by 0,0796 divided by 2. Okay, you can, if you are using a financial calculator, plug in this whole thing in your financial calculator. You don't want to be wasting time and entering everything. You can enter in one step and then get your answer, or use the financial calculator to calculate the future value, and then your answer there is equal to 545,172,54. That is the amount that Denise is going to get into her account after 40 years. Okay. I wonder how old is she right now? I wonder, but this is the amount that she's going to get. So this question is similar to the previous one. The only thing here, we are calculating the future value, but the compounding periods, because I am concerned about the compounding periods and the of the payments and also of the interest rate. So that's where things will start to be a little bit challenging, but we do have a solution to that. We don't need to stress. And then let us look on the following example. Okay, here is another example. Let us read the question. The question is saying, determine the accumulated value approximated of 500 payments. Okay, here you've got the payments made at the end. The minute you see the end, you know what you are talking about, the ordinary annuity of each month. That means the monthly payments, the payments are made monthly. That is the compounding periods of a month, that is 12. For a period of 8 years, our T is 8. The interest rate is compounded semi-annually at 13% per annum. There is a problem. Okay. The interest rate, the units of the compounding amount of the compounding unit, it is semi-annually. The other one, it is monthly. So there is a discord there. So you need to convert. Okay, you need to convert your interest rate. So then the interest rate of semi-annually, so then it reflects the same as the one of the payments. You leave don't touch the payments. Let the payments to continue at the specified period. Change the interest rate to an equivalent nominal rate that is a month. From semi-annually, you need to convert from semi-annually to the month. The interest that you are going to get after you have done that conversion, it still needs to be divided by the number of compounding periods, that is 12. Make sure you don't forget that. Here is the formula. This is a formula that was discussed from the previous session of the compound interest and the compounding periods. So this is the nominal rate Jn of that compounded n times per year is equivalent to a nominal rate of Jm compounded m times per year. So this is the formula that you must always keep in mind. The minute there is these two are not the same. Okay, so let us first put this thing into the timeline. Okay, we are working with the end. And end, we know it's an ordinary. So already in your mind, you are thinking of a ordinary annuity, and we are looking for an accumulated value. An accumulated value, that means we are looking for the future value. Okay, so we are here, and then this is till the end. We are looking for future value. That's what we are looking at. And then the period is 9 years. So your TN is equal to 9. Now, we are not making any payments. So the payments, we are doing them monthly. And those payments are 500. Let us write this into a mathematical form. We know that what are we looking? Determine the accumulated value. Which question am I doing here? Which question am I doing here? Okay. So here you are going to have, you don't know this. It's good to know what you are looking for by breaking things down. You don't know your FV. You know your R is equal to 500. You know that your M is 12. So every unit of compounding periods, even the interest should be 12. So if ever there's anyone that is speaking a different language, you need to convert it to 12. And then we know that we've got an interest rate which is equal to 0.135. However, this is semi-annually. It needs to be converted to 12. Okay, it must reflect the same unit as the compounding unit of the payments. Okay, so there's something that needs to be done there. So what else? You need your T. You know that your T is equal to 9. Okay, and then once you've got 9, your M and your 9, therefore you can have your N. Your N is 12 multiplied by 9. Yeah, you've got your 12 multiplied by 9. Okay, so before you do anything, there is this problem that you need to. What is 12 multiplied by 9?
No. How is our T 9 or 8?
It's 8. This is 8.
Thank you.
It's 8. Yeah, it's 8. This is 8. So this is going to be 8. So one thing that is standing between us and getting the solution, we need to deal with this creature. This creature is a problem because it is compounding semi-annually. It's not the same as the payments. The payments are compounding monthly. So we need to convert this to be of a nominal rate that is 12. Okay. How do you do that? You do that by taking this formula. Here's a formula that helps us to convert to the nominal rate. So now we are going to have, we want to have a nominal rate of that is compounding monthly, which is equal to, okay, our N is equal to 12. Okay, this is our N is 12 into 1 plus, this is the given, this is the one that we are talking about here, which is 0.135, and then this one, that M, it is compounding semi-annually. Semi-annually, we know that is equal to 2. So now you've got your 2 there. Okay, you've got your 2, this whole thing, and then you're going to have minus 1. Okay, so here you are going to get an interest rate that is equivalent to this semi-annually, but in a monthly form, which is equal to 0.13526. Remember, this is a new interest rate. It's compounding monthly. So when you are going into your formula, it still needs to be divided by by 12. Okay, I've seen many misconceptions whereby people say, no, I've already converted it. Why do I need to divide by 12? You still need to divide by 12 because it is a new interest rate. It is compounding monthly. So now, once you are here, you get your formula. Your formula, you're looking for the accumulated value. So your formula, when you substitute everything into your formula, is going to be equal to 500 into, okay, 1 plus, you take this new interest rate, you're no longer working with this one because it's been converted. This is going to be 0. I like to put at least to as many decimal places as possible, so then I can
Hi, Lizella. Sorry
Hello?
to disturb you. Hi, it's Boyi here.
Yeah.
I'm just for clarity. Don't we substitute the numbers in the power M over N?
M over?
M, the
Yes.
power there.
Mhm.
Did we use
Our
it?
M here is 2, ne?
Oh.
Divided
over
by
N.
12, ne? Happy?
It's 12 divided by
Is M, ne?
over
This M,
N.
ne? Which is 2 divided by N, which is this 12.
Okay.
Are you happy?
Is it going to be 12 divided by 96? Because our M is 12, and then our N is this 12 multiplied by 8, which is equals to 96. I'm lost also.
You know what? There's something that I need to. I'm going to write a report to your lecturer. Ukuthi manje, you see this formula, and then you compare it with this formula. You see that you've got to M as it is the same N, so it can be confusing. So
Yes.
pretend as if you are not in this space. You are not here. You are here. You are working with this part only. Okay. Don't take this as if it is this M. Okay. So the formula, the way it is written, it can be confusing. Okay, if you are going to be comparing it with this formula that we are using here, I'm going to write a report so then all our formulas become, there's a consistency, so then people don't get confused, especially if ever you need to bring in 2 formulas at once. Okay, pretend as if this one does not exist at this point in time. You are only working with this. You just want to convert, you want to convert this one into this one. Don't worry about the notation. Okay. It confused me also.
Okay,
So
thanks,
I'm
Lisa.
aware I'm going to write a report so then we keep consistency. Okay, we need to be consistent with these formulas. So then when someone is studying on their own, they don't question what but our M is equal to 12. Why are you saying it's 12? This is a different scenario, but the formulas are not coherent, are not consistent with each other. Ne? I'll make a note of that. So this is, we are here now. We are out of here. Okay. We are out of this. Let me get a different pen. Okay. So we went out of this discourse. We are getting into this discourse. Okay. So we are done here. Let's move and forget about the formulas. Now we are going back to this. This is where we are going back. Okay. So now this, our M here, forget about this, is done. We got our new interest rate. This should be divided by 12. Okay. And then this, according to the formula, is to the power 12 multiplied by 8, I think is equal to 96. So this is going to be your 96. Okay. This is your 96 minus 1 divided by, is this, this is it's 0.13526 divided by 12. Okay. So at this point, if you are not using your financial calculator, plug in everything into your calculator, then you can get your answer. However, there is a short-term way if you've got a financial calculator, which you have, and I hope you know how to use it to calculate the future value. So from here, your answer is 84,218.28. Okay. This one, we are still talking about ordinary annuity. The only thing we needed to convert the interest rate, which is semi-annually, into a compounding, which should be the same as the months. That's what we needed to do. Hence, we went out of this discourse into that discourse. Okay, let us look at another example, which is reflecting the same thinking.
Sorry, Lisa Kamiti here. Can I ask you a question? Can we go back to number 3? Quick question. So does this 2 over 12 stand for semi-annually? 2 divided by 12. Is
The
it
2, it is this 2, which is semi-annual.
okay? It's semi-annual. It stands for
Remember
semi-annual.
here we the discourse now is about converting this semi-annual. We are converting this creature which is semi-annually. Semi-annually, it means your thing is 2. Okay. We are only taking out this only. Go and panel beat it outside of here. We only take this one and panel beat it outside and put it here. Ne? Forget about what is happening. So this is all about here. So semi-annually, your M is 2. So this is where we are. So we want to convert it into 12. So our N is 12 here in this space, 12. And then this is your M for this interest rate. Okay. We've just isolated it from the whole discourse and put it here.
So basically, we're trying to move from semi-annually to yearly.
We tried to move from semi-annually into monthly.
Oh, into monthly. Okay.
Yeah.
All right.
Let's say your payments, for example, if your payments were made each month, but your interest was compounding quarterly, we would have to convert the quarterly rate to reflect the monthly payment rate, compounding periods.
Okay.
Okay. So you isolate that thing this is a problem. This makes this question a problematic. It makes you not to proceed because you cannot compare semi-annually and monthly at the same. They need to be reflecting the same units. Okay. So now what you do, you isolate this thing and get out of this discourse, isolate it and put it here and start to do the calculations on the side. Once you get this new interest rate, this is a new interest rate which is compounding monthly. Okay, you still need to divide it by 12 in this formula.
Oh, okay.
You must not say, I've already done the calculation I've done, but why should I repeat? No. Because it is as if it's being presented to you fresh. It still needs to be divided by 12. Okay.
Thank you very much.
Let us see another example and see if ever this is making sense. Okay. Here's another example. Okay. This is the example. What is the present value of payments of 250 made at the end of every quarter? Okay. So the payments here are made every quarter for 12.5 years at 7.5 compounded semi-annually. Okay, the payments are made every quarter. However, the interest rate is compounding semi-annually. It means we need to panel beat. The interest. So then it becomes the same as this unit. It must be the same as the number of payments. That is always your guiding. Your number of payments does not change the periods. You need to change this one, so then this one reflects the quarter. Okay, let us write this into the timeline first. So here is our timeline. This is our TN. Okay, our TN, the time there, it is 12.5. And you've got your T0 there, that is the current time. And then we are looking for the present value. And then you've got your T1, you've got your T2. So the difference here is quarterly. The payments are being made quarterly. You'll start making your payment here because they say it's an N, that is an ordinary. It's an ordinary annuity. So now let us write this thing in a mathematical form. We are looking for PV. We don't know what is our PV. Okay, we know it's an ordinary annuity. Our payment, which is our R, is equal to 250. Okay, and then these are made. Okay, these are made every quarter. Okay, and our time is equal to, our time is 12.5. We can get our N. Our N is equal to 4 multiplied by 12.5.
Hi, Lisa, sorry
Yebo?
again. As it's written as a dollar, we don't convert it.
I don't worry about that. I just wanted a
Okay.
question which was, I came across a question somewhere. Don't worry about the
Okay.
dollars. It is still the money at the end
Okay.
of the day. So you don't need to worry about that. It could have been euros, it couldn't be whatever. So don't really worry about that, ne? You need to worry about these, the number of payments, the years, and whatever. The units does not really matter. Okay? We are just taking the value here. Okay, so this is going to be equal to 50. Okay, however, there is this problem. Our I is equal to 0,075. It is compounding semi-annually. Then you know, good day, I've got a problem. I need to take this thing into a panel beating. So when you are taking into a panel beating, you isolate it from this context, take it out, convert it to be quarterly rate, because this is your main driving force. Okay, so now let's go and panel beat it SID. Okay, I'll go and panel beat it using a different pen. Okay, so when I'm panel beating it, remember we've got a formula for panel beating. I'm not going to write the full formula. We want to convert this thing into how many? Is it quarter? Ne? It's quarter. So we are looking for J4. I'm not going to rewrite the formula, guys. So we've got J4 is equal to 4 into 1 plus, we want to convert this, is 75, guys, ne? 75, okay? 0,075, okay, according to the formula, divided by, how many times is this creature compounding? It is compounding
4.
This one. It is compounding twice because it's semi-annual.
Oh, semi-annual.
Ne?
Not every quarter, yeah.
This is 2, okay? So this is going to be equal to M, which is 2, divided by N. My N is 4, okay? So this is minus 1. So I am converting this. I'm converting this one so then it becomes a quarterly rate, which is going to be, okay, so then I'm going to find is 0,074 3098. This is a new interest rate. So our interest rate here, which is compounding quarterly of 0,074. I'm putting it as many decimal points as possible, so then I do not lose the accuracy. Okay. So I've got everything here. I'm done with this one. I'm no longer going to use it. I've panel beat it. So I get the formula. The formula that I am going to be using, I am going to use a formula for the present value. The formula for EPS, I'm just doing this thing. Don't expect you to be substituting everything. I just wanted to show the substitution. And then there are ways how to calculate from your financial calculator of an annuity, as long as you've got all this information. Okay, so your P is going to be equal to 250. Okay, 250 into 1 as 0,074 3098 to the power. Remember, this still needs to be divided by 4. Just because you have panel built it still needs to be, you still need to divide by that 4, and then this 50 minus 1, then you divide, okay, 0,074 3998, okay, divided by into 74 3098, okay, divided by 4 to the power 50. This is when you want to take a long route of doing a calculation. Otherwise, from here, you can just plug into your financial calculator. You know it's an ordinary, so now you are going to change your calculator to be calculating an ordinary, and depending on the main, follow this process. You'd find this easy. You don't need to do this thing, guys. I don't want you to say, and now this thing, do I have? You don't really need to. It's just to show you the mathematical thinking behind these formulas. So you'll find that your answer, if you just plug from here, your answer is going to be equal to 8096,11. Okay. So even if this was an annuity due, even if it's a deferred annuity, look for the compounding periods. Are they the same? If you've got different compounding periods, you still go through this formula. Okay. So what I want to highlight here is these needs to be the same. This must be the same as this one. And this must reflect the same number of units as the number of payments. So the number of payments does not change. If the number of payments are every day, that is going to be 365. You need to convert your interest rate to be compounded. That I am going.
Yeah. I think I've seen where my problem
to
is.
move.
It's
Pardon?
okay. From the beginning, I would use where we said 2 divided by 4. I would use it immediately as let's say, for an example, I would say what's this? I would say 4 divided by 12.5. I think that's where I used to get it wrong, and then the whole thing will just be wrong. But I understand when you say you must penalty the first part, get rid of that, then you can be able to carry on with your formula.
Yeah.
So now I get it. Yes.
Yeah. Okay. Because it is a problem, then it needs to be isolated. Go and panel build it. It's like you're taking your car for a service, and then they tell you it's got a problem with a specific thing, then it needs a special, maybe need an electrician. So you isolate it from where you took it, then you take it for a panel beating for a different, they need to fix that part. After it has been fixed, you take it back to the original mechanic. Okay, you isolate this, and then after you have isolated it, you get a new interest rate. This becomes your new interest rate. That's what I've written here. This is your new, you no longer use this one. Irrespective, is it a deferred annuity? Is it an ordinary? Is it an annuity due? Look out, these needs to be the same. That's what we are emphasizing. Okay, otherwise from here, guys, you don't need to come here. Here you enter in your calculator, you've got all of the components that you need. As long as you know what is it that you're looking for. If you know what you're looking for, it's easy to get an answer straight in your calculator without going through the formula.
Thank you very much.
Okay. Then there's annuity due. Okay. Annuity due is just saying good, you are going to be making payments at the beginning of the period. Okay. That's what happens mostly if ever you are rent normally by Funa at the beginning of the month. So as long as you are paying those periods, then at the beginning, you know what is an annuity due. Why is this one the same? The grill is the same. It's equal size payments or deposits or withdrawal. It does not matter as long as it's something that is the payment, and then there is a compound interest. The compound interest periods needs to be the same as payment periods. Similar thing. Once the compound interest period is not the same, it needs to be converted. So then it reflects the same as this one. This one does not change. Okay. The payments are made at the beginning. Why it's necessary for you to be able to know this? When we are plugging into your calculator, you need to change your calculator to be at the begin mode. However, the calculation, nothing changes. The formulas, if you are going to be doing the formulas, it's important, guys, you don't have to memorize. It is important to differentiate these formulas, okay? Differentiate annuity due present value. The only thing that makes this one different, look at this one. This one is for ELAND. It's for the ordinary annuity. So you must know, okay, we formula here lento, here annuity due. I only multiply, I include this part, this factor. Otherwise, this one, it is an ordinary. Okay, I'm just saying this so then you do not get confused when there's a question which is asking you to differentiate between different formulas. The one of annuity due, there is this factor that is included. That's what makes it different. Okay, so but you don't need to remember, guys, the formula. You don't need to memorize it. You know, that's that thing of memorizing things. Okay, let us look at the example again. Okay, the example, I'm on page 5 already. I'm on page 5. Okay, so we need to draw a timeline. A timeline makes our life, you are clear with kwenzakalani. So now you need to determine a present value of 4 equal payments of 2,000 per year at 8%, compounded once per year, where payments are made at the beginning of each year. This is what is critical here, is for us to identify what kind of annuity is this. It is made at the beginning. The time that the payments are made tell us what kind of an annuity we are talking about. This one is an annuity due. Okay, we know that. Let us write a timeline. So a timeline, we are saying, you are making a payment at the period. At time T, you are making a payment, and then you are looking for the preference value at that period. And then this one is T1. This is annual payments, and then this is you are told in Toguti it is 4 equal payments. That means you've got your TN is equal to 4. Okay, so it is 4 payments. That's what they're saying here. It is 4 equal payments, and then your payments is 2,000. Is compounded once a year. Let us write this thing mathematically. You are looking for present value. Awiyazi. Okay, your payments, it is equal to 2,000. Okay, your interest is equal to 0.08. It is compounding annually, that is once. If it's every year, once every year, that means your M is equal to 1. And what else do we need? We know that our T, that means the number of payments, it is 4. I'm going to write T is 4. And this implies that your N is equal to 4 times 1. Okay? And then that's all. You don't need to convert anything because your payments are made once per year and your interest is compounding once a year. Even your payments are made yearly, so you don't need to be converting anything. Everything is speaking to each other. So what you need to do here is just to get your formula. Your formula is equal to, at this point, guys, from here, you can just plug this thing into your calculator. However, you must know what you are working with an annuity due. Make sure what you put your calculator at beginning. Okay, from here you can get your answer. But let us see the formula. The formula is going to be equal to the formula for the annuity due is for the present value. This is going to be equal to 2,000. I'm not going to rewrite the formula. Okay, so this is equal to 1 plus 0.08 divided by 1. Remember, your m is equal to 1 here. To the power, your n is 4, okay, minus 1, and then we divide here by 0.08 divided by 1 into 1 plus 0.08 divided by 1 to the power 4. This whole thing, there's an extension. Remember, this is an annuity U, so you need this extra factor, 1 plus 0.08 over 1. Even from this step, you don't need to be doing a long thing. No one is going to use testing your knowledge of how to do a calculation, because there's a calculator that can do this thing. Actually, you could have got your answer straight from this step. From here, from this information, you could have got your answer. And then after you have done all the manipulations, you're going to have your 7154.19. Okay, so what was important with this question is to know what you are looking for and what type of an annuity is this. Then you know what formula to use and also what keys to press in your calculator, so then you can get your answer. You don't need to convert any interest. Everything is similar. The compounding periods are the same, so you don't need to be worrying yourself. So this one was straightforward. Even with the future value of a due annuity, the process is still the same. Okay, the process is still the same. You need to watch out for any interest rate that is not the same, compounding periods that are not the same. Otherwise, get the correct formula. I'm not going to get an example for a future value because it is the repetition. Then there's another type of ilento. Another type of if annuity, the annuity, I think if nalaba abo president bethu who are getting paid until they die is perpetuity. Or I know that there are some of our parents whereby if their husbands die from at work, then they are told that the wife is going to be getting money every month until even themselves they die. Those are perpetuities. Okay, so those are the annuities, perpetuities, because you get payments until we don't know when. When we are saying to infinity is when you are no longer existing. Okay, so this one I think is a little bit straightforward. This one is straightforward. The formula is not intimidating. Okay, the only thing that you need to watch out for here is the compounding periods. Okay, and you don't need to convert anything. You take whatever compounding periods of your interest as it is. So you don't need to be worrying yourself, oh, I need to convert. It is straightforward. It's one of those questions that you just need to read and understand, is this forever? Or those keywords that are about things that are going on and on. Read the context. So the context here is saying this is Cassidy. She was awarded 750 by whatever fund to be paid out as he chooses. Okay, that is the present value of this annuity. The money is worth 9.4 per year, compounded half yearly. Half yearly, remember, it is 6 months, 6 months, half yearly. That means your compounding periods there is equal to 2. And then Cassidy chooses to be paid a fixed amount every 6 months for an indefinite period. This thing is telling you indefinite is to forever, to infinity. Determine the amount he will receive every 6 months. Okay, what you need to do here is to identify what you are looking for. You are looking for the payments. Okay, your interest rate, that's what you are concerned about. Your interest rate is compounding half yearly. That means your M is 2. Okay, and your I it is just 0,094. Okay, your P is just equal to 750. It's 750,000. Okay, this is straightforward. So your P is equal to R over JM over M. Okay, so this is equal to you're looking for your R, ne? So your P here is 750,000, which is equal to your R is, you don't know your R, and then this is divided by, I'm just writing this thing to be in one line. This is divided by your J is 0,094, your M is equal to 2, okay? This implies that your R is equal to 750,000. What is this? This is multiplied by 2. How do you write this? Multiplied by 0,094 over 2. Okay, you plug this thing into your calculator, you'll get that. You get 352.50. So this one is just straightforward. It's just to play around with your calculator, and you need to be able to read the story, what the story is saying. So there's nothing much there. Action starts taking place here. Okay, action starts taking place here. Here we've got a deferred annuity. Okay, I'm going to speak a little bit about the deferred annuity, so then it becomes clear what is it that we mean. Okay, so here they're saying you've borrowed money and have to pay it back in equal installments in equal time intervals, but you can only start paying it back after a while. You don't start immediately. Okay, you start maybe after 6 months or after some time to start making the payments. That's what we call it deferred annuities. Why is it unique and different from the other two? It has got 2 parts. Okay, you've got 2 parts in this one, and then we still work with compound interest period, and then you've got an annuity period. So the equal payments in equal intervals for the annuity part. Okay, you've got the compound interest. The payments are deferred for a period. The compound, we are still doing the same thing. The compounding periods must be equal to the payment periods. Even on this one, you still need to convert. They need to be the same. What do we mean? We've got a situation like this. This is the deferred. Let's say you are here. Okay. At deferred, you've got a single payment at the beginning. Okay. That is a single a payment at the beginning. So now this is the start. Okay. At the start, you've got the present value of this lump sum investment. Okay. Of this lump sum investment, and then this is a single investment. Okay, it's like a normal a compound interest investment. So you'll do the compound interest during this period. So it's the single payment here invested. Okay, it's a single payment invested. There are no payments. Okay, until the end of that investment period. Okay, this will be the end of the period of the deferral. We call it a deferral period. You are deferring payments during this period. During this period, you are deferring, you are not paying. Okay, you are not paying for anything during, it's a period of deferral. And then after here, remember a present value, you get a future value. So here, this investment is going to mature, it's got a future value. And at this time, okay, at this time, this is going to be the start of the present value of your annuity, whatever your annuity is. It can be an ordinary annuity. So your ordinary annuity is going to start here. Okay, let me get a different pen. Your ordinary annuity is going to take place depending. Let us say your annuity is paid at the end of the period. You are paying every period. So this will be the beginning. This is your T0. So you start making payments here until the end. Okay. So this is when your annuity is starting. This is where your annuity is starting. And then this becomes your end of your annuity. Okay. This is the end of your annuity. Okay, so this also can be is your future value of your annuity. You find it here. Okay, so now here those are those two parts. Okay, so you start paying from here, but if it's an ordinary, you would only start paying at the end of this period. That was the end of this one. So here, whatever you find, the future value of these investments is your present value of this new payments. Okay, so there's always two parts. Okay, there's always two parts. So now how do we see these calculations? Okay, let us look at one example. Okay, where is my example? Where is my example? I've got this guy. Okay, phrase. Okay. Don't worry about the units of the money. Let's just understand the story. Okay, Fraser is 33 years old and just received an inheritance from his parents' estate. Okay, he wants to invest an amount of money today such that he can receive 5,000 at the end of every month for 15 years when he retires at 65. So now he is 33 now. He does not want the payments to start now. He wants to defer them until he's age 65. He will start making payments when the payments will start coming in when he's 65. And then at the end of for 15 years, it is going to be after 65. He wants the payments for 15 years after 65. So if he can earn, this is extra information, if he can earn 9% compounded annually until the age of 65, and then 5% compounded annually when the fund is paying out, how much money must he invest today? Okay, we are looking for the present value of the investment. We are looking for, let us write this thing into our timeline. It's always helpful to write this. Okay, this Fraser guy is 33. Okay, he is 33 now. This is now. Okay, this is, we are looking for this value here. Okay, this is what they are looking for. This is the money that he must invest today. We are looking for the investment amount. Okay, but we don't know how to calculate it. But we know what he wants to invest until he is 65 when he retires. Okay, so when he's 65, these things needs to mature. So you are going to get the future value of this investment. Okay, so this future value, whatever is going to be, will be the beginning, because now after 65, he wants to be getting some money payments. So this future value is going to be a present value of, look at this, he wants to receive 5,000 at the end. At the end, that means this is going to be an ordinary annuity that is going to be starting now. Okay, so that's what he wants. And then he wants these payments to start. These are the payments. These are the payments. These are the payments. These payments, he wants them to continue for 15 years. Okay, so now after 65 years, he wants these payments to be continuous for 15 years. That means if you add 15, so this whole period from here, okay, from here until here, it is 15. So 15 plus 65, it gives you the total number of the investment, which is 80. That means you are adding 15 to 65, so then we can get the whole period from 33 until here at the age of 80. That's when the annuity is going to stop paying. Okay, but however, the annuity is running for 15 years. This 15 is for the annuity. Okay, so this is going to be 5,000, 5,000, 5,000, 5,000. It's an ordinary annuity. That's what we have identified. Okay, we are looking for this creature, and we don't have enough information for us to be able to oh, so we don't have enough information, because if ever we want to start this first part, we are going to be having problems. So we are going to start with our ordinary. Let's start with our annuity. We have identified this thing, which is our ordinary annuity. Okay. What is the information that you know about this ordinary annuity? This ordinary annuity, we know that our interest rate is equal to, you are told here that this is 5% compounded annually. So your interest rate, it is 0.05. It is compounded annually. Okay, it is compounded annually, and the payments, okay, are equal to 5,000. Okay, and then if your payments are, they are 5,000 every month. Okay, so it means now your M is equal to 12. Okay, which is different from the interest rate. It means you first need to isolate your interest rate and get the equivalent interest rate. You are isolating everything. You are here on your annuity. So your M is 12. What else do you know? You know, Guti, your thing, the payments are for 15 years. So your payments is equal to 15. Okay. And if your payments is equal to 15, what is your N? Your N is going to be equal to 12 multiplied by 15. Okay, which is equal to 180. Ne? And you know, Guti, you've got a problem. Okay, you cannot go on until you have addressed this. This is problematic here. This is a problem. Okay, so you need to convert this. Here is annually. It means the M here is equal to 1. Okay, so what do you do here? You would go and convert it using our formula. Okay, so you're going to convert it using our formula. This is the end. Remember our formula? For converting, we are isolating this thing, taking it to a panel beta. We are going to say we want to convert this thing to be a monthly rate. So you're going to have your J12. Okay. Your J12 is going to be equal to 12 into 1 plus, you are isolating this 0. You've got 0.05. 0.05 divided by 1. It is compounding annually, therefore your M is equal to 1. This is to the power M, which is 1 divided by 12. This is your 12. I don't want to run out of the page. Minus 1. So you convert, you plug it into your calculator, and then you find that your new rate is going to be 0.0489. This is your new rate, which is compounding monthly now. So you've got your rate. Now you can go now and calculate your annuity without wasting time, guys. You can plug in, you've got all of the components. This is your new rate. You are no longer using this one because you've isolated it. So you can go to your calculator, plug in the new rate. It's compounding monthly now. So you divide that, which is by 12. you do your calculation, or you can go and plug into your formula. Your formula for an ordinary, you are looking for a present value, okay, of your ordinary. That means you are looking for this value here. So your ordinary is going to be equal to, I'll just substitute 5,000, that is the number of payments, that is the actual payment, okay, which is equal to 1 plus 0,0489. You still need to, I will emphasize this thing all the time, this still needs to be divided by the compounding units, that is 12. So this is divided by 12. Okay, this is divided by 12, and then this is to the power. What is your n? Your n is equal to 180. So this is 180 minus 1. Okay, this is an ordinary annuity, not an annuity Q. So you know the formula to use. So this is divided by 0,0489 divided by 12 into 1 plus 0, divided by 12. Guys, you don't need to go through this thing. I'm a mathematician. I like algebra so much, Mina. So I always want to emphasize things from that perspective. Ne? So you don't need to be worrying yourself about this formula, because you've got beautiful calculators. So here you will get your ordinary. That means you want this value. Your value here is going to be 636, okay, 925,79. It is this value, okay. This is also the same as the future value of this first part. Remember, this investment you had no payments, okay? This becomes the future value. Once you've got your future value, you go and work with your normal investment, okay? What is happening with your normal investment? That is the period of deferral. We call this one a period of deferral. Let me get a different pen. This part is the period of deferral. Awubhadali next. Yebo?
I want to ask, why would you then why would you multiply it by 12? So why did you change it into compounded monthly?
Can you specify the number?
I'm saying you compounded monthly. Why did you do so? Because
why did I
saying
do
that it's compounded annually.
Remember, we are saying the compounding, the interest rate, the compounding periods needs to be the same as the payment. The periods needs to be the same. Ne? Here, the payments are made every month. Can you see that?
Yes,
the payments are made every month, but the interest is compounding annually. So they are not the same. They need to be the same. The compounding periods needs to be the same. Ne? So how to make them the same? You only convert this one. So then it reflects this one. Ne? So now, because you've got every month, this one is compounding annually, it needs to compound monthly. So then it reflects the same units as this one. Do you get me? Hello?
Yes, thank you.
Hence, you needed to isolate this formula. You needed to isolate this thing, go and beat it, and get the equivalent interest rate, which is compounding monthly. So then it becomes the same as the number of periods of payment. Okay? So you get out of there, you are done with your annuity, you are coming at this deferral period because you want to get here. Okay, so what information do you know there? The information that you know how long this investment is taking place. The investment here is taking place from 60 is 65 minus 33. Okay, 65 minus 33 is equal to 32. That is the period of this investment. It's not an annuity, but a normal investment. Okay, and you know that your interest, you are told with the interest of your if he earn 9% compounded annually until, that means here the interest is 0.09, and this thing is compounding. It is compounding annually, so your M is equal to 1. Okay, and what else do you know? You know what is your future value. Here is your future value. Okay, what do you need here? You need a formula of a simple interest that you know. Okay, so now your simple interest formula, simple compound, the compound interest formula. So your S, which is, I'm going to use I'm going to use this notation. Okay, the future value, okay, is equal to present value into 1 plus IN. That's the formula we are using, because we are looking at the normal investment, which has no payments. Okay, so from here, you know what is your future value. Your future value, it is this present value of your annuity. Okay, so I'm going to move this thing here, guys. I need space. I don't want to move into another page, because I don't want you to lose me. I don't want us to lose each other. Okay, so I just substitute my future value. It is this one. Okay, so now I've got 636,925,79, which is equal. I am looking for my present value. I'm looking for this one, which is 1 plus the interest rate is compounding annually. It's just I'm dividing by 1, so I don't need to be worried about any compounding periods. It's 0.09 to the power. What is my N? My N is equal to 32. This implies that my present value now is equal to 4405.54. That's what you were asked. You were asked to get this. Let's talk about this one. Okay. I'd like to invite some participation from the masses about the story that is being told here. It is this one. She has enrolled in this degree. Okay. She realizes that she does not have enough money to pay for her studies. She persuades her grandmother to lend her money. Yay! Kushkuti labo gogo that have money. Ours don't have money. So her grandmother has got money. So she persuades her grandmother to lend her money. The condition is that she will only start paying back the loan after 5 years. Can you see here of study? So now she's not going to pay the money like now. She'll start paying it later. That is it. She's deferring the payments. Okay. Then her yearly payments of 50,000 each at the end of each year will be for 4 years. Okay. Her grandmother wants to earn 12% per year on her money. How much money is the grandmother willing to lend her now? They're looking for the present value. Okay. Okay. There are 2 parts here. Okay. We want to, let's answer questions that are related to the annuity. What kind of an annuity is this one?
Ordinary annuity.
Yes, it is an ordinary, because this 15,000 is paid at the end. It's annually at the end of each year. Okay, so this is an ordinary annuity, and at the same time, it is deferred. Okay, it is deferred because this lady starts paying, says Uzo will start paying grandmother after after 5 years when she finishes studying. Okay, that will be the T5 of the end of the lump sum investment. Okay, but we don't know how much did the grandmother give her. Okay, we want to know who to grandmother umnikeze how much. Okay, for that period of 5 years. Okay, we don't know, but we know that our N here is equal to 5. Okay, and our I, there's nothing that is saying the I is different. Grandmother, what she knows, she just wants her thing at an interest rate of 12%. So now we will assume that the interest rate is the same for both parts. You've got two parts. You've got this one for the investment. So this one is going to have the future value, which is going to be equal to the present value of the ordinary. Okay, it does not necessarily have to be an annuity that is ordinary. It can be annuity due. Okay, check out what is it from the story that is being told. Okay, so now here there are payments of 15,000. She's making payments. She's making payments, and then at the end of each year will be for 4 years. So she wants to pay for 4 years. Okay, that means it's 5. It's going to be here. It's going to be your N for the thing. Your N, which you can just say is your T. The time for the payments is going to be equal to 4, which means this is going to be 9. Okay, from here to there, that's going to be your 9, but that is not helping us. We're just putting it just to play around with our timeline. So your T here for this part, let me have a different pen so then we can see that we are working with this. We are here now. We are here. We are concerned about this ordinary annuity. Okay. We are told what interest rate iafana. So now the interest rate for this part, this rate part, that is the annuity, the interest rate is equal to 12%. Okay, it is equal to 12% per year. That is compounding annually. So your M is equal to 1 then. So our M is equal to 1. Okay, and then our T is this one. Our T is equal to 4 because she said she's going to make payments for 4 years. That is 4 payments. It will be 4 years. That is 4 payments annually. That is 4. And what else? We know that our R is equal to 15,000. Okay. And what else do we need? We don't need to be worried about converting because our interest rate period is the same as the period of the payments. So there's no need to go and isolate an interest rate and do some conversion. So what we need to do here, we need to get this. Okay, so the P, the present value of the ordinary is equal to 15,000 into 1 plus, remember it's an ordinary, so you're going to be using the formula for ordinary, 12 to the power, your N there is equal to, your T is 4, which is 4, okay, minus 1 divided by 0.12 into 1 plus 0.12 to the power 4. You don't need to do this algebraic calculation. You can get the ordinary PV just from these components. Once you've got this, you've got this, you've got that, you can plug these things into your calculator and get the value of your P ordinary. So if you are using the longer method of loving algebra, this is how you would go about. So this is going to be 45560.24. Remember, this is similar to your future value. This is your future value of your investment. Okay, so you've got the value of your future value, which is this one. So you need to get, after you are done here, you need to come to this stage. Okay, you come here to get the information, the present value. There are no payments here because there is a deferral. It's a period of deferral. All you need to do is to get all of your components. You've got your N, which is 5. You've got your I. You've got your present value. You've got your future value, which is the one that you've just calculated. So your investment formula, it is your future value is equal to PV into 1 plus I to the power N. Okay, so your future value is what you've just calculated from your annuity, which is 45560.24 is equal to, you are looking for your present value, which is 1 plus, the interest rate is the same, nothing has changed. It is 0.12, okay, to the power, your N is equal to 5. This implies that the present value is equal to 25852.10. Okay, so Loma Gogo is prepared to lend her grandchild 25,000. Inabo gogo bethu abanayo le mali le. You can't even borrow. So she gives her grandchild 25,000. Then the grandchild will start paying that amount after 5 years. And then the amounts equal payments of 15,000. Okay. So we went all through this trouble because we wanted to know Guti umagogo imali engaka, where does she get it? Wherever, maybe it was an inheritance from the husband, but this grandmother is rich. So you can take the mathematics and put it into a social economic class and talk about the nature of this grandmother and say, what kind of a grandmother is this one? So that's where we talk about, we are saying maths, we are, what do they call it? It's there's a word of that maths whereby you take maths and put it, it's like maths literacy, and put it into our everyday language and say, here is the money, let's talk about this grandmother, maybe she needs to be investigated. Those kind of things. Perhaps they even need to hire us, even Gule case Besta, and try and calculate where the money came from and all that stuff. So that is my last example, guys, on the deferred annuities and the annuities. I think what was problematic here was the conversion of the compound interest, or of the compound interest to be the same as the compounding periods of the payments. That is the only thing that I found would give you difficulties. Otherwise, this thing is just straightforward, I guess. What is important with this topic is to be able to decontextualize the mathematics from the story. Once you are able to decontextualize it correctly, you are good to go. You use your financial calculator, or you can go to Calculator Soup. Calculator Soup calculates most of all of the financial concepts. Even for algebra, you can even share it with your kids. If they want to calculate for the trigonometry, whatever, there is an online calculator.
Okay.
Yeah.
Thank you.
Thank you so much, guys. Thank you.
Thank
Thank you.
Thank you, Doctor.
Okay.
Bye.
Bye-bye.